In this episode, we focus on a security idea that sounds like basic organization, but becomes a major survival skill once systems grow. Separating interfaces, functions, services, and roles so that damage stays contained when something goes wrong. When everything is tangled together, one mistake, one bug, or one compromised account can spread impact across the whole system, like a spill that reaches every room because there are no doors. When parts are separated thoughtfully, the system can keep operating in a limited way even under stress, and defenders get time to respond without having to shut everything down. This is sometimes described as containing blast radius, meaning you design the system so failures and compromises have a smaller zone of effect. You do not have to picture rockets or explosions to understand it. Just imagine the difference between a house with fire doors and a house with open hallways everywhere. The goal here is to show you what separation means in a real security engineering sense, why it matters for both attacks and accidents, and how you can reason about separation even if you are not the person writing code or building networks. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good first step is to define the words in a practical way because they can blur together for beginners. An interface is the surface where someone or something interacts with a system, such as a login page, a programming interface, an administrative console, or even a file drop location that triggers processing. A function is a capability the system provides, like viewing a record, updating a record, generating a report, or approving an action. A service is a component that performs work, such as a background worker that sends notifications or a separate component that stores data. A role is a set of responsibilities and allowed actions associated with an identity, such as a student, instructor, reviewer, operator, or administrator. Separation means you avoid lumping these together into one giant doorway with one giant set of powers, and instead you create boundaries so that each interface exposes only what it must, each function runs with only what it needs, each service has a limited job, and each role has limited authority. The result is that a weakness in one area does not automatically become a weakness everywhere. Why does this contain blast radius? Because attackers and accidents both thrive on unnecessary connections. If the same interface that regular users touch also provides administrative actions, then a single vulnerability in that interface could give access to high-impact functions. If a single service handles everything from file uploads to database administration, then compromise of that service could allow an attacker to move freely across the system's most critical operations. If one role includes both day-to-day tasks and emergency powers, then compromise of that role becomes catastrophic. Separation narrows the pathways, and narrowing pathways makes it harder for a problem to spread. It also creates natural checkpoints where monitoring and controls can be placed, because each boundary is a place where you can validate inputs, enforce permissions, and log actions clearly. Without boundaries, everything becomes a blur, and blurred systems are hard to defend. Separating interfaces is often the most visible form of separation, and it is a place where beginner intuition can be trained quickly. Imagine a system that has one web portal for everyone, where the same menu can show both student features and administrator features depending on who logs in. That sounds convenient, but it means the user-facing surface is also the administrator surface, which increases risk because the most exposed area now includes the most powerful actions. A more separated design might have an administrator interface that is reachable only through a different path, with stricter controls and additional checks, and a user interface that is simpler and has fewer capabilities. This is not about making administrators suffer. It is about reducing exposure and reducing the chance that a flaw in a highly exposed interface leads to full control. Separation can also apply to machine interfaces, such as a programming interface used by mobile apps versus a different interface used for internal management. When interfaces are separated, you can apply different rules, different monitoring, and different limits based on the risk of each interface. Separating functions is about making sure actions with different risk levels are not treated as if they are the same kind of action. Viewing public content, viewing private content, exporting data in bulk, and changing account permissions are all functions, but they have very different consequences if abused. If the system design treats them as equally accessible, you are effectively giving attackers a menu of high-impact actions. Separation can mean that certain functions require stronger verification, additional approvals, or are available only to specific roles. It can also mean that high-risk functions are not even implemented in the same place as low-risk functions, reducing the chance that a bug in one path accidentally unlocks another path. Beginners sometimes think of permissions as a list you check off, but separation is deeper. It is designing the system so high-impact actions are naturally isolated. When functions are isolated, you can test and validate them more carefully, and you can monitor them with more attention because you know they matter. Separating services is a major way modern systems limit blast radius, even though you can understand the logic without memorizing any particular architecture style. A service should do one main job, and it should communicate with other services through controlled pathways. If one service is compromised, the attacker should not automatically gain the ability to perform every other job in the system. For example, a service that handles user profile updates should not also have the ability to issue administrative privileges, because those responsibilities are unrelated and the second is far more dangerous. If the profile service is compromised, you want the impact to be limited to profiles, not to the entire access control model. Separation also helps with resilience, because services can fail independently, and the system can degrade gracefully rather than collapsing entirely. From a security perspective, independent services can be given independent permissions, independent monitoring, and independent recovery procedures. This reduces the chance that one compromise becomes a full system takeover. Separating roles is about making sure identities are not given a mixture of responsibilities that create dangerous combinations. If someone can both request access and approve access, then the process becomes vulnerable to abuse and errors because there is no independent check. If someone can both develop changes and deploy changes directly into production, then a single compromised account can alter the system in a way that is hard to detect and easy to persist. Separation of roles is a form of checks and balances, where the system design expects that mistakes and bad behavior can happen, and it ensures there are barriers to prevent one actor from doing everything. This does not mean you need a huge staff for every small system, but it means that for high-risk actions, there should be an expectation of independent verification. Even in small teams, role separation can be implemented through process controls and technical restrictions that reduce the chance of a single error becoming a disaster. The key idea is that trust should not be concentrated without a good reason. A common misconception is that separation automatically makes systems secure, as if simply having more parts creates safety. Separation can fail if boundaries are weak, if there are too many exceptions, or if the same secrets and privileges are shared everywhere. If every service uses the same credentials, then compromise of one service gives access to all, which defeats the point. If the administrator interface is separated but uses the same session mechanism as the user interface without added protections, then flaws can still cross boundaries. If roles are defined but everyone is still placed into a broad role for convenience, then the role model exists only on paper. Effective separation depends on independence, meaning boundaries must be supported by distinct permissions, distinct trust assumptions, and clear rules about how requests cross from one area to another. Separation is not about creating more boxes. It is about making sure the boxes actually stop something from spreading. Another important angle is how separation affects how you investigate incidents. When boundaries are clear, you can follow the trail of activity more easily, because actions are associated with specific interfaces and specific services. If a suspicious export happened, you can see which role performed it, which interface was used, and which service executed the action. That clarity helps defenders contain the problem because they can isolate or disable a specific component without shutting down everything. It also helps you make confident statements about impact, which is important during incident response because uncertainty can cause either panic or dangerous delay. In contrast, tangled systems produce tangled evidence, where it is hard to tell whether a suspicious action was a normal background process or an attacker. Separation acts like labeling and compartmentalization, making it easier to reason about what should happen and what should not happen. That reasoning is a core part of security engineering because defenders need to detect deviations from expected behavior. Separation also interacts with the idea of least privilege because it is difficult to apply least privilege when responsibilities are mixed together. If one service is responsible for many unrelated functions, you often have to give it broad privileges to accomplish all of them, which increases risk. When services are separated by responsibility, each one can be given a narrower set of permissions, which reduces blast radius by design. Similarly, when roles are separated, you can create more precise permission sets that match actual tasks rather than giving everyone a broad bundle of access. Interfaces benefit too, because you can design them around the minimum set of functions needed for their audience. Over time, these decisions create a system that is easier to secure because each part has a clear purpose and a limited scope. When parts have limited scope, compromises are less likely to become systemic, and that is what it means to contain blast radius. This is why separation is not a standalone trick, but a deep design habit. It is worth discussing trade-offs, because separation can increase complexity if done carelessly, and complexity can create its own risks. If you separate into too many pieces without a clear plan, you can end up with confusing interactions and fragile dependencies. The goal is thoughtful separation, where each boundary is justified by risk and where the interaction between parts is simple and consistent. A good design chooses boundaries that match natural responsibilities and stable trust relationships, rather than boundaries that change every week. When boundaries match real-world responsibilities, they are easier to maintain and less likely to be bypassed through exceptions. When boundaries are stable, they can be monitored and tested effectively because the expected patterns of communication do not shift constantly. In security engineering, the best separation reduces risk without creating chaos, and that balance requires design discipline. The lesson for beginners is that separation is not about slicing everything into tiny pieces, but about making sure high-risk powers are isolated and that exposed surfaces are kept as small as possible. As you wrap this up, keep the central picture in mind. Separation is how you build doors and fire breaks into a system so that problems do not spread unchecked. Separating interfaces reduces exposure by keeping powerful functions away from the most public pathways. Separating functions isolates high-impact actions so they can be protected, monitored, and controlled more strictly. Separating services limits what a compromised component can reach, making attacker movement harder and containment faster. Separating roles prevents concentration of trust and authority, reducing the chance that one compromised identity can do everything. When these ideas work together, the system becomes more predictable and more resilient, and it becomes harder for small failures to become big disasters. The most important beginner takeaway is not a specific architecture pattern, but the habit of asking where the boundaries are and whether those boundaries actually limit harm. If you learn to see systems in terms of surfaces, responsibilities, and contained zones of impact, you are building the mindset that makes security engineering practical and effective.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.